Alright, let's graph 3 tangent of 2x plus pi over 6 minus 2. Let's do some identifying steps here. Our k is equal to negative 2. Remember, that's our horizontal axis. That's our new horizontal axis because we're shifting down 2. Our absolute value of a is equal to 3. Negative 2 plus 3 equals 1. And this is our high point. Now remember, or notice I didn't say max. That's our high point. And negative 2 minus 3, that's equal to negative 5. And this is our low point. Notice I did not say minimum point. Alright, now let's get an indication of our interval. So, our period, now remember, period for tangent is pi, and so our period for the transformation is going to be simply pi over 2. Our interval length will be pi over 8 because you simply take the period and divide it by 4. Now, what are the points? What are the 5 points in that interval? Well, for tangent, in order to see the complete curve, it's best to do your period from negative pi over 2 to pi over 2. Now notice I didn't put less than or equal to. That's because tangent is undefined at negative pi over 2 and pi over 2. Those are our vertical asymptotes. But this is how we're going to find our new set of points. And then subtracting pi over 6 from both sides and dividing by 2, I get negative 4 pi over 12 and 2 pi over 12. Now, what you should notice is that your denominator for the interval is 8. Denominator for the endpoints of this period is 12, so we need a common denominator. And clearly that common denominator is 24. So I'm going to go ahead and change these points with a denominator of 24. So this is going to be negative 8 pi over 24 and 4 pi over 24. And our interval will be 3 pi over 24. Alright, so we have negative 8 pi over 24. We add 3 pi, we get negative 5 pi over 24. We add 3 pi, negative 2 pi over 24. And then positive pi over 24 and 4 pi over 24. Now with tangent curves, because we're our last points, our first and our last point will be our vertical asymptote. This will be our asymptote, and this will be our asymptote. Now with tangent, a positive tangent, it goes low point, then horizontal axis, then your high point, Remember, our low point was negative 5, horizontal axis was negative 2, our high point was 1. And these are our asymptotes. Alright, let's go ahead and graph this. So notice that I have my new horizontal axis at negative 2. My asymptotes are at negative 8 pi over 24 and at 4 pi over 24. Now, at negative 5 pi over 24, I'm at negative 5. This is negative 1. This is negative 1, negative 2, negative 3, negative 4, negative 5. So I'm going to put a dot right there. At negative 2 pi over 24, I'm on our new horizontal axis. At pi over 24, I'm at 1. And at 4 pi over 24, I'm at my vertical asymptote. Now, it's probably a good idea just to figure out the y-intercept. That's pretty easy. You just substitute 0 in for x. And in this problem, I've already done the work, but the y-intercept is in decimal form about negative 0.27. So we'll say it's like right there. And then it has a very similar shape to a cubic. I wouldn't call it a cubic. But there you go. There is one period of this tangent function.